Hello. This is Nolan Driscoll and John Caravan, and we have chapter 12, which is significance tests in practice.
All right, so the first section in chapter 12 is 12.1. This is about one sample t-test. So the equation you will need for this part of the chapter is t equals x bar minus mu divided by s over root n. So in this equation, the t that you're looking for is the t-test statistic. The x bar is the sample mean. Mu is the population mean. And S is the sample standard deviation, and N is the number of observations you have. And then also, since this is a t-test, it relies on degrees of freedom, which is N minus 1 for this test.
12.1 notes, and we just want to discuss when we use a one sample t-test, and that is when finding the population mean from a single sample without knowing the population standard deviation, aka sigma. In this case, we use S, which is the sample standard deviation. So it's a four-step process, and the first step includes the null hypothesis and the alternate hypothesis, also stating what test you're doing, and the alpha. So for the null hypothesis, it's just population mean equals the stated mean. And then the alternate hypothesis is the population mean is greater than or less than or does not equal the stated mean based on the sample mean value, which they'll tell you in the problem. Step number 2, you need to meet 3 conditions in order to use this test. The first is data from an SRS. Is it normal, or are there 30 or more observations? Or the last one is independence, and that is or independence or the population is greater than equal to 10 times the sample size. Step 3 is the calculations, where you find the test statistic and the p-value. To find the test statistic, use the equation that Johnny talked about, which is t equals x bar minus mu divided by standard deviation of the sample divided by radical n. And then this gives you the test statistic, and then you plug it into this bell curve right here, and it will give you the p-value with inverse norm and that kind of stuff. Or inverse t. Inverse t for this one. Thank you, Johnny. Step number 4, you do the write-up about the p-value. If it's less than alpha, you reject the null hypothesis. If the p-value is greater than alpha, you fail to reject the null hypothesis.
So now moving on to 12.2. This is about the z-test for population proportion. Instead of using a sample, you have proportions about a sample of people. So the equation for this one is z equals p hat minus p0 divided by the square root of p0 times q0 over n. So in this equation, the z that you're trying to find, this is the z-test statistic, which is different from the t-test statistic in the last part of the chapter. Then p hat is the sample proportion you're given. P0 is the population proportion. And then in this equation, it might look different from what we looked at before because it has Q0, but Q0 is just 1 minus P0 like we saw before. N is the number of observations, just like the last problem. And once again, degrees of freedom is N minus 1.
Great work, Jonathan. 12.2 notes, one proportion z-test. When do we use this? We use this when we are given a single sample proportion or percentage in a problem to infer about a population proportion. So again, we'll go over this 4-step process. And step number 1 is you state it, one proportion z-test or population proportion at alpha, whatever it is. Usually it's 0.05. Next, we do the null hypothesis, which is P equals the sample proportion. And they'll just give you that in the problem usually. And then the alternate hypothesis is P does not equal, is greater than, or less than the sample proportion. Usually they'll hint at that towards the problem. They'll say like, some people believe it is greater than, and that's how you'll figure out the alternate hypothesis. So step number 2, we have data from an SRS. Conditions normal or n times p hat is greater than or equal to 10, and n times 1 minus p hat is greater than or equal to 10. And I just realized that I forgot about independence, and that is just n. This population size is greater than or equal to 10 times the sample size, the same as the one sample t-test. Step number 3, the calculations. As Johnny just said, use this long formula. And then to find the test statistic, then use the bell curve to find the p-value. And if the p-value is less than alpha, you reject the null hypothesis. And if the p-value is greater than alpha, you fail to reject the null hypothesis. It's very similar. You got to build on top of it.
All right, so if you guys watch this presentation and still need some practice to study even after our test, the Chapter 12 packet that we use to teach ourselves this chapter earlier in the year has a bunch of problems you can use. But if you already did all those, there's some pages in the textbook listed here that you can use for review. This is mainly the chapter review and the section review from these chapters we went over.
Fantastic. Oh, yeah. Time to do some practice problems, everyone. And here are our citations. Thank you for listening. How do we end this puppy?